to Essential Problems with CRIP. In this video, we're going to use our ideal gas law equation and incorporate that with various gas stoichiometry problems. Let's begin. 51. Consider the following reaction, where 4 moles of aluminum react with 3 moles of oxygen gas to produce 2 moles of aluminum oxide. It takes 2 liters of pure oxygen gas at STP to react completely with a certain sample of aluminum. What is the mass of aluminum reacted? Again, identify what's given to you. You have 2 liters for the volume. At STP, temperature and pressure, standard temperature and pressure for gas is 273 Kelvin for the temperature and pressure 1 atm. So we're given the temperature and pressure in addition to the volume. The only missing variable here is our moles. So substituting in for our pressure, volume, R value, and temperature, we can find the number of moles of oxygen gas. And if we convert the moles of oxygen gas using the balanced whole number ratio, the ratio of how they're going to react from the balanced chemical equation, we can then convert this to moles of aluminum, right? And then using the molar mass of aluminum, we can convert it to grams of aluminum. And since there are 3 significant figures, this should have been 2.00, right? 2.00 right there. Since there are 3 significant figures, that's the limiting. We are going to round to 3.21 grams of aluminum. 52. A student adds 4 grams of dry ice, solid CO2, to an empty balloon. What will be the volume of the balloon at STP after all the dry ice sublimes, converts to gaseous CO2? So the reaction is to go from CO2 solid to CO2 gas. So 1 mole to 1 mole. If we're given 4 grams, we can convert that to moles of CO2, and we're given temperature and pressure since it's at STP. The only missing variable here is the volume, which we're being asked to solve for. And it's straightforward from there. 53. Airbags are activated when a severe impact causes a steel ball to compress a spring and electrically ignite a detonator cap. This causes sodium azide, NaN3, to decompose explosively according to the following reaction, in which 2 moles of NaN3 produce 2 moles of sodium and 3 moles of nitrogen gas. What mass of this must be reacted to inflate an airbag to 70 liters at STP? 70 liters are volume, pressure 1 atm, and temperature 273 Kelvin. The missing volume variable is moles of N2. And it's really important here because what's the only gas in this reaction system is the nitrogen gas. We are solving for moles of nitrogen if we're using PV equals nRT, and then we would need to convert using the balanced chemical equation to moles of sodium azide and then to grams. 54. Concentrated hydrogen peroxide solutions are explosively decomposed by traces of transition metal ions such as manganese or iron, and here we have our reaction provided. What volume of pure O2 gas collected at 27 degrees Celsius and 746 torr would be generated by the decomposition of 125 grams of a 50% by mass hydrogen peroxide solution? Ignore any water vapor that may be present. So again, we're given temperature, which we should convert to Kelvin immediately, and 746 torr, which we need to convert to ATM, especially if we're using PV equals nRT. And we're given also 125 grams of solution. It's important to note that's of solution. And in order to find the hydrogen peroxide in that solution, we need to take 50% of that solution. And of course, we can then convert that mass of solution, or the mass of hydrogen peroxide in that solution, right, using the molar mass of hydrogen peroxide to moles of hydrogen peroxide. But this is still not O2. We need to use the balanced chemical equation, given that 2 moles of H2O2, hydrogen peroxide, will generate 1 mole of O2 gas. Then we can convert that to moles of O2 gas and then use our ideal gas law equation to solve for the volume of O2 gas that would be generated. 55. In 1897, the Swedish explorer André tried to reach the North Pole in a balloon. The balloon was filled with hydrogen gas. The hydrogen gas was prepared from iron splints and diluted sulfuric acid. The reaction is provided. The volume of the balloon was 4,800 meters cubed, or cubic meters, and the loss of hydrogen gas during filling was estimated at 20%. What massive iron splints and 98% by mass hydrogen peroxide were needed to ensure the complete filling of the balloon. Assume a temperature of 0 degrees Celsius, a pressure of 1 atm during filling, and 100% yield from the given reaction. Okay, so we're given the volume of the balloon, which of course we could take the cubic meters, 4.8 times 10 to the third, and we can convert that to liters given the fact that 1 cubic meter is equal to 10 to the third liters. We're also given temperature, right? 0 degrees Celsius, which we need to convert to Kelvin, 273 Kelvin, and pressure, 1 atm. We are also given a very important fact here, which is that the balloon, the moles in the balloon, right? The moles in the balloon will be equal to only 80%, right, of the total H2 that was necessary. And this is perhaps the trickiest piece of information to interpret, because when we are using the volume of the balloon and the temperature and pressure, really we're just solving for the moles in the balloon, but not the total. The total H2 is really important, which is what was required to get that balloon going, the total amount. And so by solving for the total number of moles, we can then work backward to find the moles of iron and moles of sulfuric acid separately, and then we can convert that to grams of iron and grams of sulfuric acid separately using the molar mass of each. And then finally, for the solution, we need to find the mass of the solution. So it's not the mass of the sulfuric acid by itself, but of the solution, which of course then you need to convert backwards to find the mass of the solution, since that would be 100 grams of solution to 98 grams of H2SO4. Okay, 56. Sulfur trioxide, SO3, is produced in enormous quantities each year for use in the synthesis of sulfuric acid. And so you have the two equations provided. What volume of O2 gas at 350 Celsius and a pressure of 5.25 atm is needed to completely convert 5 grams of sulfur to sulfur trioxide? So we've got the temperature, right, which of course we need to convert to Kelvin, and we've got the pressure, 5.25 atm. We're solving for volume, so we need moles of O2. So of course we could convert grams of sulfur to moles of sulfur, but there's an important distinction to make. And so most students would just simply say, assume that we need 2 moles of O2 to every mole of sulfur. But that is incorrect, because if we convert the moles of sulfur to the moles of O2, that would be the exact moles of SO2, right? That would be produced. But then that moles of SO2 would react according to a separate equation in which 2 moles of SO2 would react with only 1 mole of O2. And so this would not be the same as this. So it's important to do those two calculations separately, but once you have those, you can find the total moles of O2, and then with that, you can find the volume of O2. Finally, methanol can be produced by the following reaction. And here, hydrogen, the hydrogen gas at STP, flows into a reactor at a rate of 16 liters per minute, and carbon monoxide at STP flows into the reactor at a rate of 25 liters per minute. If 5.3 grams of methanol is produced per minute, what is the percent yield of the reaction? First of all, totally disregard per minute, because obviously everything is being measured per minute. So if we assume 1 minute, we can just disregard the per minute. And notice also that we have 2 substances here. So we have the hydrogen and the carbon monoxide, which means that we have a limiting reagent calculation. We need to determine the limiting reagent in order to predict the amount of methanol, the maximum amount of methanol that would be produced in this system. So once we have that, that would be the theoretical amount. And of course, we should convert that to grams. So based upon whichever is the limiting reagent, we can then calculate the grams per minute of methanol produced. But that would not be the actual. So notice if actually 5.3 grams of methanol is produced per minute, we're then being asked to solve for the percent yield, and percent yield would be the actual divided by the theoretical, the general. Till next time,